In the early 1960s, Japan was rebuilding itself at a pace the world had never seen. Factories were running at full capacity, wages were rising, and for the first time, millions of ordinary Japanese families could realistically dream of owning a car. Toyota understood that moment precisely. The company had already established itself as a serious manufacturer, but what the market needed was something specific: a compact, reliable, affordable automobile that asked nothing extraordinary of the person buying it. That car became the Corolla, and what began as a response to a particular economic moment would eventually become the most successful automobile nameplate in history. The E10, introduced in 1966, was engineered around a philosophy of honest engineering. Toyota chose a rear-wheel drive layout with a front-mounted engine, which was the standard configuration of the era and one that engineers understood thoroughly. The suspension used McPherson struts up front and a 4-link live rear axle, a setup that prioritized durability and low maintenance cost over outright performance. The body was designed to minimize weight without sacrificing structural integrity, and the 1.1-liter K engine, a straightforward overhead valve unit, was tuned for longevity rather than peak output. Every component was chosen because it could be manufactured consistently, serviced easily, and trusted to last. That reliability-first approach was not a marketing decision. It was an engineering mandate, baked into every specification. The E20, arriving in 1970, reflected Japan's growing confidence and an expanding export market. The car grew slightly in all dimensions to accommodate the comfort expectations of buyers in the United States, Australia, and Europe. Toyota introduced a twin-cam engine option, demonstrating the company's ability to produce high-revving, refined power plants at a competitive price point. The chassis received improved front geometry and a recalibrated rear axle to handle the additional weight while maintaining predictable handling. Noise and vibration reduction became a priority, as export buyers compared the Corolla against domestic competitors with more refined interiors. By the time the E30 arrived in 1974, the first global oil crisis had fundamentally changed the automotive landscape. Fuel economy shifted from a secondary consideration to a primary engineering objective almost overnight. Toyota responded by refining combustion chamber geometry, improving carburetor calibration, and reducing internal engine friction. The E30 also introduced improved aerodynamic shaping, achieved through intuitive design rather than sophisticated wind tunnel analysis. Structural rigidity was quietly improved, allowing suspension tuning to work more effectively without interference from chassis flex. The E50 series, introduced in 1979, came during regulatory pressure and growing competition from European manufacturers. Toyota extended the body options significantly, offering sedans, coupes, wagons, and liftbacks, each with unique suspension tuning. The engines became cleaner as emissions regulations tightened, requiring engineers to balance combustion efficiency against exhaust output. This challenge demanded more precise carburetor design and careful valve timing calibration for the final years of the decade. The E70 generation, introduced in 1979, represented the final major evolution of the traditional rear-wheel drive Corolla architecture. Rather than completely reinventing the formula, Toyota focused on refining it to perfection during this era. The chassis became more rigid, suspension tuning was improved, and the body was engineered to meet increasingly demanding safety and emissions regulations. The E70 also expanded the Corolla lineup with a broader range of body styles and engine options, serving a wider variety of global markets. Perhaps most famously, this generation produced the AE86, a lightweight variant whose balanced chassis earned legendary status among driving enthusiasts. Although Toyota was developing front-wheel drive technology, the E70 represented the pinnacle of the Corolla's traditional rear-wheel drive engineering. The E80, introduced in 1983, marked one of the most consequential transitions in the Corolla's history. Toyota moved the mainstream lineup from rear-wheel drive to front-wheel drive, fundamentally reorganizing the car's architecture. This was not a simple change. Front-wheel drive places both steering and driving duties on the front wheels, introducing challenges like torque steer. Toyota's engineers devoted considerable effort to refining constant velocity joints and steering calibration to minimize these effects. The benefits were substantial. Front-wheel drive allowed a lower floor and increased interior space without enlarging the exterior. While the legendary AE86 coupe retained rear-wheel drive, the E80 established the front-wheel drive template that would define nearly every mainstream Corolla following it. The E80 also brought the twin-cam 4AGE engine into sharper focus. This 1.6-litre power plant, developed with Yamaha's engineering expertise, delivered a level of performance that surprised many observers. With its high compression ratio and aggressive camshaft profiles, the 4AGE demonstrated that efficiency and driver engagement could coexist. Toyota also refined the McPherson strut front suspension to enhance ride quality and cornering stability, completing this epic technical transition. The E90, arriving in 1987, helped make electronic fuel injection the standard across much of the Corolla lineup. This was a pivotal step. Carburetors, while adequate, are fundamentally mechanical devices that cannot adapt in real time to changing conditions. Electronic fuel injection uses sensors to monitor engine conditions continuously and calculates the precise amount of fuel to inject for each combustion event. The result is more consistent power delivery, better fuel economy, and lower emissions across a wider range of operating conditions. It also made the engine more responsive and easier to start in cold weather, which mattered enormously for buyers in northern climates. The E100, introduced in 1991, benefited from Toyota's deepening investment in computer-aided engineering. Chassis stiffness improved measurably, while body weight actually decreased in several areas, achieved through careful analysis of load paths through the structure. The suspension received further tuning, and noise and vibration reduction became an engineering discipline in its own right. Engineers mapped resonance frequencies through the body and addressed them through targeted stiffening, damping material, and revised mount geometry. The E110, produced from 1995 to 2002, introduced variable valve timing with intelligence, which Toyota branded VVT-i. A conventional engine has fixed valve timing, meaning the intake and exhaust valves open and close at the same points in every engine revolution. VVT-i allows the management system to adjust intake camshaft timing in real time, optimizing for torque, power, or efficiency based on driver demand. This technology improved both performance and fuel economy simultaneously, something that had previously required a significant engineering compromise. The E120, launched in 2000, continued Toyota's refinement of the Corolla's chassis. Selected models adopted a multi-link rear suspension, while others retained a torsion beam layout to balance cost, packaging, and performance. A multi-link system uses multiple independently mounted links to control wheel movement, giving engineers far more flexibility to tune camber, toe, and tracking. The result is a more composed rear end, reduced body roll, and better ride quality over varied road surfaces. This generation also pushed interior quality higher, with improved materials and better noise isolation that narrowed the gap with European competitors. The E140, introduced in 2006, coincided with an era of intensifying fuel economy regulation in the United States and Europe. Toyota continued refining the dual VVT-i system, which added variable timing to the exhaust camshaft in addition to the intake. This allowed even more precise control of the combustion process, maximizing efficiency across the rev range. Aerodynamic drag reduction became more sophisticated, with wind tunnel testing used to refine body surfaces and mirror design. Structural rigidity increased again through the use of higher strength steel, providing better crash protection without proportional weight gain. The E170, produced from 2013, introduced the continuously variable transmission as the primary automatic option in many markets. A traditional automatic transmission uses discrete gear ratios and shifts between them, whereas a CVT uses a pair of variable diameter pulleys. The steel belt provides an infinite range of effective ratios, allowing the engine to operate at its most efficient speed. This improves fuel economy, particularly in urban stop-and-go conditions, where traditional gears might hunt for the right ratio. Toyota refined the CVT's programming to reduce the characteristic sensation of the engine revving without an apparent increase in acceleration. This addressed a common complaint about earlier designs, blending efficiency with a more natural driving feel. The E210, introduced in 2018, was built on Toyota's new global architecture, commonly known as TNGA. This represented a fundamental rethinking of how Toyota designs and engineers its vehicles across multiple model lines simultaneously. Rather than developing each platform independently, TNGA established common structural principles, shared suspension geometries, and standardized mounting points that could be adapted across different vehicle sizes. The benefits were substantial. The Corolla's center of gravity dropped, its body rigidity increased dramatically, and the suspension geometry was designed from the outset to work together as a cohesive system rather than as individual components tuned separately. The E210 also introduced a fully hybrid powertrain option across most major markets, pairing a 1.8-litre or 2.0-litre Atkinson cycle engine with a compact electric motor, and either a nickel metal hydride or lithium-ion battery pack, depending on the market and model variant. Toyota Safety Sense, a suite of active safety technologies, including pre-collision warning with automatic emergency braking and radar cruise control, became standard equipment. What the Corolla's story ultimately demonstrates is that engineering progress rarely arrives in a single dramatic moment. It accumulates through decades of careful observation. It accumulates through honest assessment of shortcomings and disciplined commitment to incremental improvement. Each generation of the Corolla identified something the previous one did not do well enough and addressed it with the tools available at the time. Rear-wheel drive gave way to front-wheel drive when the packaging advantages became clear. Carburetors gave way to fuel injection when electronics became reliable. Fixed valve timing gave way to variable timing when computational power made real-time control feasible. Conventional platforms gave way to TNGA when the cumulative cost of fragmented development became unsustainable. The result of more than 5 decades of that process is a vehicle that has sold over 50 million units in more than 150 countries. Not because it was ever the most exciting car in its class, but because generation after generation it was consistently and honestly engineered to serve the people. It remains a testament to the power of steady, relentless engineering excellence for those who depended on it.